Welcome. In this tutorial we are going to learn about Heapq. It's an implementation of Heapq algorithm, which is also known as a priority queue. In Python, heap is implemented as a min heap, which means if you pop an element out of heap, it will be the element which containing the minimum or the lowest value. So Heapq module provides functions which provides the functionality of push and pop an element out of heap, and it performs the operation on the list object. So what is heap? Heap is a binary tree where each parent node with the value or the priority in the tree is less than its all children when comparing the value or the priority. So for example, this is a binary tree satisfying the heap property, where we can check each parent value or the priority with its children. If it is compared, it will always be less. So if we compare the value for parent 6, it is less than its child's 11 and 15. For 2, it is less than 6, 7, 11, 15 and 8, and so on for other parents too. If we check for all parents, it will be less than. So as I explained earlier, Heapq module expects element to be stored inside the list, and it will perform operation on list which will modify the order of element, or if you are performing push or pop operation, it will add or remove an element out of list. So we can construct a binary tree out of list using these two formula. So if you want to calculate the immediate children of any parent node, you can calculate their indexes where that child is stored using this formula for the zero based index. So let's check the slides for it. Okay, here we can see we are having list with the element in a heap order and their respective indexes. So first element will be always stored at the index 0. So this is the first element of our tree. So we want to find out its left and right child. So we have formula for that. For left, 2 into I plus 1, where I is the index of the current parent, and right, for right children, it is 2 into I plus 2. So index begin from 0. So we will put the value for I. If we calculate it, so left child is at index 1 and right child is at index 2. So if for at index 1 element 2 is there, and for index 2 element 3 is there. So we will put those into our binary tree. Now let's construct child for element 2. So if we calculate it, it will give us index 3 and 4. So if we see the element, there are 6 and 7. So we'll put it there as their child. For element 3, which is at index 2, if you calculate its children, they are at index 5 and 6, which are 5 and 9. And for element 6 at index 3, if we calculate their children, they are at index 7 and 8, which are 11 and 15. And for last element of list, which is child of element 7, which is stored at index 4. Okay, so this way we can construct a binary tree out of given list. So this is the same list. Okay, now let's discuss the time complexity of operation for the Heapq. So it inserts an element into the heap in a log n. in a worst case scenario. We will only discuss the worst case scenario. So for deletion, it performs in log n time. To find minimum, it performs in a constant time, because we know always the first element of a given list will always containing the minimum value. For sorting, it takes n log n time, and for searching, it takes big O of n. Now let's begin with the functions of heapq. So first one is a heapify, which construct the heapify list out of the normal list. So here we are having a list element which is containing elements in a random order. So if we apply heapify method on the existing list, it will order their element based on their value, which satisfy the heap property. So if we execute it, it will arrange each element based on their value, such that if we construct a binary tree out of it, it will be having order same as we saw for the heap property. So it will construct the same list as we saw for the example. This is the binary tree for this random value. Next function is heappush, which adds given element to the heap, maintaining the heap property. So if we have currently, if we are having a heap which is maintaining the heap property, and if we want to insert a new element to it, then we can use heappush method, which will insert element in such a way that it obey the property of heap. So now we will construct a heap from the empty list. Earlier we were constructing list from the existing list. Because it is not obeying the heap property, we have executed heapify method. Now here we are beginning from empty list. So if we are using heap functions, we don't need to heapify. Okay, it will ensure that while inserting element, it will maintain its heap property. So if we push random element to the heap, and if we print the list after pushing elements, as we can see, it has constructed the list. Okay, and if we draw out the binary tree for it, it will look like this. So if we check the heap property for any parent node, it will be having value less than its all children. Next method is heappop, which will remove and return the smallest element from the heap, maintaining the heap property. So after removing the smallest element, which will always be at index 0, the heap tree need to be restructured. So let's see the example. So here we know 1 is the smallest element, so it is removed. After removing it, the binary tree need to be restructured in such a way that each parent element is having value less than its all childs. Okay, so if we draw out the binary tree for it, if we can see here 1 is removed. So after that, 2 become the root node of the binary tree. Okay, and according to that, the elements are changed. So 8 was at index last element of the list, so it is no more the last element of it. So the elements are also internally shuffled based on the value of the element. Okay, So it will ensure that after removing the minimum element, the binary tree satisfy the heap order. Next function is heappushpop. It pushes element E to the heap and pops the smallest element from the heap. So if we want to push an element and afterwards we want to remove the minimum element, we can use the combined method of heap push and pop, which is heap push pop, which will work more efficiently than executing heap push and heap pop individually. Okay, let's execute it. So it will first insert element 10 inside the heap and then it will remove the minimum element and it will also restructure the heap tree. So if we see the binary tree of it, first of all it will insert element 10 and it will remove the minimum element, which is 1. So it will restructure 2 times. So after performing restructure of 2 times, the binary tree will look like this. Next is heap replace, which pops the smallest element from the heap and pushes the given element E to the heap. So heap push pop was first pushing the element and then removing it, whereas replace will first remove the element, smallest element, and then it will push the new element. So if we push 0 here for the heap push pop, it will first insert 0 inside the heap and it will also remove 0 from the heap because 0 is the minimum element. So same element we have pushed and same element we have removed. So with heap replace, first we are popping the minimum element from the heap. So if we execute heap replace for element 0, first it will extract the minimum element from the heap, which is 1, and then it will insert 0 to the heap. So after performing operation, your heap will look like this. Because we are inserting lowest element, rest of the binary tree will not change much. Next function is merge, which returns the generator function, which returns single sorted elements from the given multiple sorted iterables. So it takes 3 arguments. First one is a variable amounts of iterable. So varargs of positional argument, which is passed as a iterables, and 2 parameters are keyword based argument. First one is a key, the same key which is used for sorting the iterables, and second one is a reverse if the given iterables are sorted in a reverse order. So that must be given the same value here. So for example, we are having 2 flowers list which are in a sorted manner, and if you want to create a generator function out of these 2 sorted iterable such that it returns element in a single sorted manner, then we can use merge method. Let's check the type of object which is written by the merge method. So it is an object of generator. So we can collect all the elements into the container type such as list or tuple. Okay. So if we execute it, as we can see, all the elements are in a sorted order combined from the given iterable. Now if the iterables have used custom key method, so key for the sorted method takes a callable which takes one argument and returns one element. Based on the return element, it performs the sort operation. So for this example, we have passed len, so it will sort list of string based on their length of the characters. Okay, so same key function need to be passed for the merge function. So same function is passed here, and if we execute it, it will return combined list because we have collected into the container list which is holding element in order of their length of the character. So as you can see here, first element is having length 4, second element is having length 4, third element is having length 5, and increasing in that manner. So here key takeaway from this is the same key need to be provided to the merge function. Same way for reverse too. If we have reverse sorted the iterable, we need to pass reverse equal to true in the merge parameter. So it will reverse sort the single sort of a given two iterables here. As we can see, the result list is reverse sorted containing all elements of given two iterables. Next method is nlargest, which returns list of nlargest element after sorting the given iterable by given key, which is equivalent to performing sorted function for given iterable with key and set reverse equal to true, and then we are slicing from beginning up to nth element. Okay, so if we execute nlargest on given iterable, which is list here, which is not sorted, so first it will perform sort function with given key. If it is not given, it will perform on a default order, and it will take slice out of given n. So let's execute it. As we can see, it is returning 3 elements which are having highest value inside list. Same way, nsmallest will return smallest number of n element from given iterable after sorting that iterable, and optional parameter key if the custom sorting function is used. So if we execute nsmallest, it will return 3. For given n equal to 3, it will return 3 elements which are smallest. Next is an example. Now we can, up to now we have stored the integer as a element of a heap, but we can also store tuple or the list as an element of a heap. So here it is a student's heap containing list as an element. So as we have compared the list in a list section, we can compare two lists which will compare the elements by their elements of each list. So first it will compare the element at index 0, then it will compare element at index 1 if the both elements at index 0 are equal, and so on. So here we have arranged the data structure in such a way that the first it is storing the roll number of student, which is unique and in a increasing order. Okay, so it will never go for the second element. And we have stored in the students list. So if we are in the order of the students are in a random, as you can see here. So if we execute heapify method on the students list, it will arrange the inner list which is holding information for a particular student in a heapify order. Okay, and if we are extracting each element out of that heap, it will return each element in a increasing manner from lowest to highest. So at last the element with the highest value will be returned. So we have executed heap pop method on each element until the heap is empty. So it will return in a ascending order. So let's execute it. As you can see, before here it was stored in a random order. After heapifying, if you construct a heap tree, binary tree out of it, it will be satisfying the heap property. And if you are extracting each element using heap pop, it will make sure that it is returning the lowest element each time when you execute the heap pop, which will be the sorted order if you are extracting all the elements out of heap. So as we can see here, the final list is sorted according to the first element of a inner list. That brings us to end of the video.